happy to introduce Professor Dr. Brian Kennedy next. He's internationally recognized for his research in the basic biology of aging and as a visionary committed to translating research discoveries into new ways of detecting, delaying, preventing, and treating human aging and associated diseases. He is a distinguished professor in biochemistry and physiology at the Yong Loo Lin School of Medicine at the National University of Singapore, NUS, and serves as the director of the Center for Healthy Longevity. NUS aging research seeks to demonstrate that longevity interventions can be successfully employed in humans to extend health span, the disease-free and highly functional period of life. Brian is a former president and CEO of the Buck Institute for Research on Aging and has a profound understanding of the potential of AI in the realms of anti-aging and longevity. He brings a wealth of experience and knowledge to the stage, so please give him a warm welcome.
Thank you. And it's wonderful to be here. I've been to Sofia before. I really enjoy coming here. And today I'm going to tell you a little bit about aging. And a few minutes ago, you just heard a wonderful presentation on aging. And so I can go a little bit fast in the introduction because much of what I want to say is similar. And I want to start with a quote by a famous novelist, Murakami, who said, "Death is not the opposite of life, but a part of it." And I think this reflects a lot of thinking about mortality that goes on in literature, it goes on in philosophy, from the Stoics to Nietzsche. It goes on throughout many aspects of our life. We may not think about death every day, but it's certainly something in the back of our minds. And what I'm here to tell you today is that aging, which is the biggest driver of mortality, may be optional. It may be possible to slow or even reverse aspects of aging. And research is moving very quickly to try to accomplish this goal. So aging, as you just heard, is the biggest risk factor for a whole range of chronic diseases that people think about all the time. Alzheimer's disease, cancer, frailty, heart disease, diabetes. And the COVID epidemic showed us something else. It's also the biggest risk factor for mortality due to infectious disease. It was by far people over the age of 65 that succumbed to COVID. And we know aging causes functional decline too. If you're my age and in my 50s, I can already tell you there are things I can't do as well as I could 30 years ago. And so if aging is driving all of these things, why are we spending all of our money trying to treat those individual diseases and not spending some of that effort trying to do something about the aging process generally? Because if we can slow aging down, we can delay all of these bad things and stay healthy longer. You heard the term health span. That's the key term here. How do we keep people healthy longer? And so what we're trying to do in Singapore is interventions while you're still healthy. Right now, most of medicine is sick care. We don't do preventative medicine that well. There's a little bit, but we don't do it that well. Generally what happens is you get into your 50s and 60s, you get some disease, you go to the doctor, and they spend a lot of money trying to treat that disease. But actually, after you get sick, it's much harder to deal with it than before you get sick. And so the clinical interventions that we're doing are on the bottom line down there. While we're still in the green zone, while you're still healthy, and the goal is to try to keep you healthy as long as possible. Now, you might live longer too, but the main point is we want to make you healthy longer. And so how do we do that? Well, it comes down to two things. It comes down to biomarkers, measuring aging, and interventions. Then there are all kinds of different potential interventions. You heard about lifestyle, exercise, diet, stress, sleep. All of these things affect aging. But beyond that, there are small molecules, natural products, drugs. And in the future, there's going to be stem cells, gene therapy, organ replacement, and maybe a whole range of other technologies that has the potential to really keep you alive and healthy much, much longer. So the problem is that we can't do a clinical study where we give you a drug and wait 50 years to see if you live longer or not. We have to be able to measure the rate that you're aging at any point in the lifespan. And the advent of biomarkers has now made this possible. we now have what's called aging clocks that can measure the rate that you're aging. Your passport is really good at your chronological age, but we all know people age at different rates, and now we can measure that. So there are lots of key questions now that are available to humans that were never available before. How do we do intervention studies to show that we can slow aging in people? Which interventions are going to work best? How do we combine them to get synergistic effects? Can we actually affect maximum lifespan? Maximum lifespan is about 120 right now. What if it were 150 or 200? This may be possible in the near future. And how do we use the biomarkers to measure what's working and what doesn't? So if you look at preclinical studies like in mice and a whole range of other species, we already got them covered. If you're a mouse, we can make you live healthy longer. We can make your lifespan extended. The problem is we have to translate that knowledge into humans. And so what we're trying to do right now is to focus on the clinical trials. Here's an example of a mouse living healthier and longer. This is a simple natural product, alpha-ketoglutarate. These mice are 27 months of age. The control mice are on the right, and the AKG-treated mice are on the left. I think you can see that you'd rather be one of the mice on the left. Their coat condition's great, they're healthy, they don't have tumors, they don't have curvature of the spine, et cetera, et cetera, et cetera. Again, if you're a mouse, we have you covered. But how do we get human? So let's talk about aging biomarkers. And you don't have to read this slide. I'm going to just summarize it for you. There were basically no good biomarkers 10 years ago or 15 years ago. And then AI came along. Deep data sets, omic-based technology, transcriptomics, DNA methylation, proteomics. You can take these deep data sets and then you can use neural networking or machine learning to estimate someone's age. Or you can estimate the potential that they're going to get sick. Or you can estimate when they're going to die from these AI platforms. And then you can use these clocks to measure how old a person is and how well they're doing. And we're now using those in clinical studies. And so if you just look on the right, there's a line that goes up the middle of that graph, and that would be someone that's aging at the same rate as their chronologic age. So that person in the middle might be 50 years old chronologically, and they're 50 years old biologically. But there are also people that are 50 years old chronologically, but only 40 years old biologically. And that's the bottom person. And then there are people that are not doing as well and aging poorly, and that would be the top person. We can measure this now. And these measures work because the things we know that accelerate aging actually accelerate the clocks as well. So drinking too much makes you older. Smoking too much makes you older. Chronic infections, chronic diseases make you older. I really recommend that you choose not to be a male, because if you're a male, you're older than a female. And so all of these things show up in the clocks. Also, if you exercise a lot, you're younger. And if you eat the right diet, you're younger. So the clocks are measuring something very meaningful. And so now we're applying them to clinical studies. So if we give people alpha-ketoglutarate, this AKG molecule I told you about a few minutes ago, they get about 7 years biologically younger by these clocks in 6 months on the product. And this is not the only product on the market. This is just the one I'm showing you. There are many other potential interventions that can affect your aging. And a lot of these are natural products. And so what we're using now is artificial intelligence in our clinical studies to measure as many aspects of aging as we can in individuals. We're taking people 45 to 65, putting them on a particular intervention. It could be lifestyle, could be a drug, could be a supplement. 6 months on the intervention and measuring whether they get younger or not. And the question is going to be, which interventions work best in which people? Who responds? Who doesn't respond? What are the personalized nature of longevity interventions? We don't have the answers to any of these questions yet, but now we have the capacity to get those answers, and it's really thanks to AI for measuring biomarkers. And so I just want to leave you with a thought that comes from the Hippocratic Oath. A really brilliant document written a long time ago, but it gets interpreted to be first do no harm. And then people think of that and they say, well, I can't do anything to somebody that's healthy. I have to wait till they're sick to treat them for some disease. And I want to leave you with the idea that doing nothing to people is harming them. We need to take a life course approach to health care, not sick care. And that means educating people when they're young so that they have healthy lifestyle. Moving them on to supplements and other interventions as they get older to prevent them from getting disease and to maintain their functional capacity. And then treating them when they get sick late in life. Right now, we're very good at the third part, not so good at the first two parts. And if we get better at those first two parts, what we'll be able to do is to make health span go up faster than lifespan. And that's compressing morbidity. So that improves quality of life better than trying to treat diseases. And it also is a major boost to the economy, because right now, as you heard, we can't afford to take care of all the older people if they have multiple diseases. But if they're healthy, they can still be working. They can still be contributing to the economy. They can still be spending money and traveling and enjoying life. And that's what the real goal is. So I just want to leave you with this. If you search my name at NUS, there's a webinar we do 3 times a month. If you're interested in aging, you can find it. And all of the old shows, there's about 85 of them on a whole range of topics of aging, are on YouTube. So thanks a lot for your time. And let's all live healthy longer. Thanks.